Okay, so now we're going to go over how to use the moles for calculations. So to help you guys do this, just as a device to help you to set up problems, I'm going to show you something called the mole is the heart. So the mole is very important in chemistry. So I want you to imagine here we have a heart, and I'm going to label this with a mole. On one side of the heart, and make sure you write this down in your notes, is mass, and that's going to be in grams. And on the other side of the heart are particles. And these are going to be either atoms, molecules, when we're talking about covalent compounds, or formula units. Okay, formula units are going to be for ionic compounds. Okay, so when we're going from moles to mass, we're going to be using molar mass as a conversion factor. So when we're going from moles to mass, we'll be multiplying by molar mass. When we're going from mass to moles, we'll be dividing by molar mass. Okay, when we're going from moles to particles, we're going to be using Avogadro's number as a conversion factor. And when we're going from moles to particles, we'll be multiplying by Avogadro's number. When we're going from particles to moles, we'll be dividing by Avogadro's number. Okay, so what you should notice is that when we're going away from the mole, we're multiplying by one of these conversion factors, and we're going towards the mole, we're going to be dividing by one of those conversion factors. And just to clarify too, when I'm talking about multiplying, so I'm going to label these as A and B, and then C and D. So for A, what this will look like is we will have what we have in our problem, and we're going to be multiplying by 6.02 times 10 to the 23rd particles per mole. And if we're dividing, we're going to have what we have in our problem multiplied by 1 mole over 6.02 times 10 to the 23rd particles. For C, when we're multiplying by molar mass, we're going to take what's given to us in our problem, and we're going to be multiplying by the molar mass, which is grams over mole. And when we're dividing it by molar mass for D, we're going to have what we have in the problem times 1 mole over the molar mass we're calculating, which will be in grams. Okay, so I want to show you guys how this works in a problem. So for the next example, it's asking us how many grams are in 3 moles of potassium phosphate. So first of all, when you're doing these kind of problems, it's very important you write out your formula for your compounds. So we have here K3PO4. And we do want to calculate the molar mass of this compound before we can begin solving. So again, we say that we have 3 potassiums, so 3 times 39.10 grams per mole, plus 1 phosphorus, so 30.97 grams per mole, plus 4 times 16 grams per mole. If we add all these three things together, we're going to get 212.27 grams per mole. Now, when you're looking at these problems, it's giving us 3 moles. So always look at what your number is with. So our number's with moles. It's asking us how many grams. So if we go back to our heart, we're starting with moles. And then we're asked to find mass, which is in grams. So we're going away from the heart, so we're multiplying by molar mass. So let's go back to the problem. So we're going to take our 3 moles, and always what you're given the problem should be over 1 times, and then we have here 212.27 grams per mole. So the mole is always going to be 1 mole in this unit. You notice here that the moles cancel out, and we're left with grams. So this is our conversion factors, just like in the first chapter. So we're going to do 3 times 212.27, which gives us 63.681 grams. And then we have to think about sig figs. The molar mass is a conversion factor, so we will not use this for sig figs. If we look at 3, there's only 1 sig fig with that. So our answer will be rounded to 60 grams. And you notice there I did not put a decimal, because if I did put a decimal, that would make the 0 a significant figure. Okay, so this is from moles to grams. Now let's do one which is grams to moles. Okay, so we have here 212 grams of aspartame, and we're going to go from grams to moles. So I'm going to insert another slide, and I'm going to okay, so here, let's look at this. Okay, so we have C14H18 N2O5. So C14H18 N2O5 is our formula. And we have 225 grams of that, and it's asking us how many moles. So always think about where your number's with, and then look for words like how many or how much. So how many moles? Okay, so we have 225. And we're trying to find equals how many moles. So if you're not using the heart, what I need you to do is to look at the units. So we have here 225 grams over 1. So what you're given the problem is always over 1, and we're trying to find moles. So we have 2 conversion factors we could use. We could use Avogadro's number, or we could use molar mass. Now, since we're given grams, the unit we're starting with should go in the bottom of our conversion factor. So we have grams here. If you notice here that this will allow grams to cancel out. The only conversion factor which has grams in it is molar mass. Avogadro's number does not have grams in it. So if we were using the heart, we can also think about we're starting with, so remember over here is grams, and we're going towards the heart, so we're dividing in this case by molar mass. So now what we have to do is calculate the molar mass of this compound. So I'm going to do 14 times 12.01 plus 18 times 1.008 plus 2 times 14.01 plus 5 times 16. And when I do that, I'm going to get 294.30 grams. And remember, with molar mass, the other side of our conversion factor is 1 mole. When we do this, we're going to now take 225 and we're going to divide it by that number. And when we do that, we're going to get 0.7645 moles. And remember, we were given only 3 sig figs, so we're going to round this to 0.765 moles. And we can abbreviate that as MOL. Okay, so that's another problem. So now what I want you to do is try one of the problems on your homework, going from either moles to grams or grams to moles. So in fact, you should try one of each. Okay, so one other thing I want to go over before the end of class is I want to go over on your homework with the moles mass problems. What you will also notice is that there's some problems where it asks you to figure out what kind of element you have or what your element is. So this is a slightly different twist. So here, let's look at a number 11 on your sheet. So it's giving you the grams, the mass, and it's giving you how many moles you have. So each element in your periodic table, what you should see, has a unique molar mass. So if we were to find out the molar mass, we would then be able to identify what element we have. So if we're given the grams and we're given the moles, we can divide these to find the molar mass. So we could take 77 grams, divide that by 2.4 moles. And if we calculate that, we're going to find we have 77 divided by 2.4, which gives us 32.08 grams per mole. And I just rounded it to 2 places past the decimal because that's what our molar masses are usually rounded as. But in this case, we only have 2 significant figures, so it technically should be 32 grams per mole. So if we look at a periodic table, what we will see is that the element with the closest molar mass to that, so it may not be exactly the same, but we see it's sulfur. So this would be sulfur. So that's how you do a problem like that. So you should be able to do the rest of these problems on this sheet. Just make sure that if they don't give you grams, for example, that you do convert it to grams before you solve. And good luck.